In section 4, we're going to talk about cones. And a cone is a solid with a circular base joined to a vertex by a curved side. So it's similar to a pyramid in that it has one base, but it's similar to a cylinder in that we have one curved side because that base is a circle and not a polygon. So when you're finding the base area of a cone, because the base is a circle, the area of a circle is just pi r squared. So when we go to find the base area of our cones, all we have to do is use our area formula for a circle. So it's going to be pi times our radius 3 squared. So our area is going to be 9 pi centimeters squared, which is approximately 28.27 centimeters squared. In our second cone, we have a diameter of 12, which means our radius is 6, so it's pi times 6 squared, which gives us an area of 36 pi centimeters squared, which as a decimal is approximately 113.10 centimeters squared. And in our last cone, we have a radius of 4, so it's pi times 4 squared, which gives us an area of 16 pi feet squared, which as a decimal is approximately 50.27. When it comes to finding the lateral area of a cone, which is that curved side when we flatten it out, so it's our area of the curved side, we end up with the formula A equals pi RL. So remember from the last section we introduced L as slant height. So let's go ahead and find our lateral area of our cones. So that means we need to know the slant height. So that's the height along the side. So when it comes to our area, we have pi times our radius 3 times our slant height 5, which is going to give us an area of 15 pi centimeters squared, which is approximately 47.12. In our second cone, we already know that the radius is 6, so it's pi times 6, and then our slant height of 10, which gives us an area of 60 pi centimeters squared, which is approximately 188.50 centimeters squared. And in our last cone, our lateral area is pi times the radius 4, but we don't have our slant height. So what we do know is that the angle formed with our radius and our side is 60 degrees, which makes the right triangle a 30, 60, 90 special right triangle. And our slant height is just the hypotenuse of that right triangle, which is 2 times the shorter leg. So that means the angle at our top here has to be 30 degrees, which means 4 feet is our shorter leg. So it's 2 times 4 for the slant height, which gives us a slant height of 8. So pi times 4 times 8, which gives us a lateral area of 32 pi feet squared, which is approximately 100.53 feet squared. So the total area of our cone, so its surface area, is the sum of the base area and lateral area. And because those areas have specific formulas, we get the formula for surface area is pi r squared, our base area, plus pi rl, which is the formula for our lateral area. So we don't have to find each of them first in order to find the surface area. We can just plug in values into our formula. So we're going to find our total area. So we have that our surface area equals our base area, which we know from before is 9 pi, plus our lateral area, which we know is 15 pi, which gives us a total surface area of 24 pi centimeters squared, which is approximately 75.40 as a decimal. For our second cone, its base area was 36 pi, plus its lateral area 60 pi, giving us a total surface area of 96 pi centimeters squared, which is approximately 301.59 centimeters squared. In our last cone, we had a base area of 16 pi, plus our lateral area of 32 pi, giving us a total surface area of 48 pi feet squared, which as a decimal is about 150.80 feet squared. Lastly, we want to talk about finding the volume of a cone. So the formula for a volume of a cone is very similar to the formula for the volume of a pyramid. We have 1/3, and then the area of the base, which since it's a circle, is pi r squared times the height. So the volume of a cylinder formula was similar to the volume of a prism, and the volume of a cone formula is similar to the volume of a pyramid because that's its similar solid with a different type of base. So we go to find the volume of our cones. We have that our first cone, 1/3 times the area of our base, which was 9 pi, and then we don't actually have our perpendicular height here. So we're going to use the Pythagorean theorem to solve it. We know the slant height is going to be the hypotenuse of our right triangle, and our radius is one of the legs. So our height squared plus 3 squared equals 5 squared. So we get the height squared plus 9 equals 25. When we subtract 9, we get the height squared is 16, and we take the square root, we get that our height is 4. So we have 1/3 times 9 pi times 4, which gives us a volume of 12 pi, and then our units centimeters cubed, which as a decimal is 37.70. So we're going to have to do something similar in our second example because we don't have the perpendicular height. So we have to use our radius and our slant height. So our height squared plus the 6 squared is going to equal 10 squared. So we get h squared plus 36 equals 100. When we subtract 36, we get that h squared is 64. Take the square root and we get a height of 8. So our volume equals 1/3 times the area of our base, which was 36 pi, times our height of 8. So that gives us a volume of 96 pi centimeters cubed, which as a decimal is 301.59. In our last example, we're not going to use the Pythagorean theorem to find our height. We're going to use our special right triangle property. So the side opposite the 60-degree angle is the shorter side times the square root of 3, which means the height of our last cone is 4 square root 3. So we get that the volume equals 1/3 times our area of our base, which was 16 pi times 4 square root 3. So that gives us an exact volume of 64 pi square root 3 all over 3 feet cubed, which as a decimal is about 116.08 feet cubed. So as you're working on the assignment over cones, let me know if you have any questions about any of the formulas or how to find any of the areas or volume.